Hello everyone, my name is Niels Stenzel, I'm from Shining3D. Sorry, I don't speak Slovenian, so I will do it in English. I have the honor today to tell you a little bit more about 3D scanning and about 3D scanners. And first of all, to start this, I want to show you my short agenda. So we have the company introduction, so who we are, the technical overview, and afterwards we're going to have a live demo of the 3D scanner. So we're going to scan this race car over here. First of all, about the company itself, we were founded in 2004, and we, Shining3D, started with laser engraving machines. Those machines we knew I think 10 years ago were really common. In every Photoshop we could laser engrave a crystal, a picture inside, and that's how we came up with the technology. So we started to develop those photo machines and the laser engravers, and that's how we started with the whole technology about additive manufacturing and 3D scanning. Currently we have over 650 employees worldwide. Our headquarters are in Stuttgart, in Germany, in San Francisco, in Florida, Tampa, in Hong Kong, and in China. And we can say that we are one of the leaders in the 3D scanning and printing technology itself. So over here we can see the headquarters in Stuttgart. We are since 2016 in Stuttgart. This is our newest venue or office where we do all the demonstrations, the service support, the repairs of the scanner. So our foundation of 3D scanning or the digitizing process is first of all for sure to digitize an object, then to design and simulate what we saw also before, then manufacture it for sure, and then inspect it afterwards because we want to be sure that the product we produced is precise and it's good manufactured. And that's why we have this circle over here. So we have a whole ecosystem to close the whole environment. If we look at our lineup, we can see we have two different scanning lineups. So first we have our einscan range, and second we have our metrology range. So what is the difference? So the difference between einscan and metrology is the certification. So for all the metrology scanners you get a certification with it. I will come on this topic a little bit later what it means. And for the einscan scanners you can buy an additional DF certification for the scanner. So what we have our desktop scanners, the einscan ESP, our multifunctional handheld scanners. We see it over here, it's handheld and you can use it as a fixed scanner. We have our handheld hybrid scanners, so the einscan H, so we have different technologies in here. And the HX, the only scanner currently on the market who can scan with laser and with structure light. Then metrology, we have the AutoScan Inspec, the scanner over here, so for small parts, it's an automatic scanner, really easy to use. Our handheld laser scanners, the FreeScan UE7, UE11 and UE Pro. And I brought a pretty new device over here, the FreeScan Combo. We can also look at it later on. And for sure our OptimScan 5M, 5M Plus, and what you already see here back, the CMM tracker. So wireless tracker which tracks the scanner. We don't need to stick markers, we don't need to prepare the part, we can just start scanning. And for sure we have also a probe for that. So if we look at I know it seems that we have a pretty big lineup, so what kind of scanner fits to my needs? First of all, you can go to, for sure, to Freeway and they can find out your application and the needs. But basically the most important things to say is the desktop scanners are mainly used for education. We do have also a lot of industrial customers. So in Stuttgart, Bosch Tools, they bought I think 200 or 210 einscan SPs to put on every table of the engineers to develop the handles of the power tools. So they normally use a foam, they cut it out and it's a free form, so they cannot put it easily in their CAD system. So that's why they scan it and reverse it back or auto-surface it back and bring it back to their real products to make it ergonomic for us. The multifunctional handheld scanner is also like a lot of educations, industrial customers, like Airbus using it a lot, the einscan Pro HD, because you can use it with the turntable, small scan mode, and with the hand scan mode. Then the handheld hybrid, 1skenH, is more for orthopedics, medical applications. And the HX is a lot for cars, manufacturing, milling, and really industrial parts. And then the metrology scanners, as I already said, the inspec for small parts with a lot of details. The free scan, really good accuracy, high volume, you need to scan large parts. Same for the fixed scanner, it's really high accuracy, and the laserless wireless tracker is for really tall parts and you don't want to prepare anything. So what we do normally, together with Freeway, we do analyze what is your need, what is the budget, what is the price, and what is the application. And then we normally do find the golden triangle, we call it, and find the perfect solution for you. I talked a little about it, and if we talk about 3D scanner, one really important part is the accuracy. So how accurate can the scanner capture the object you want to inspect? And if we talk about accuracy, we talk about the deviation between the real value of the object, or the real accuracy itself, or the true value compared to the scanning value. And how do we certify our scanners, or how do we know that the scanner is accurate or is fits to the specs we tell you on our spec sheet? So I forgot this, but you can also see a good example of accuracy itself. You see, I always explain it like with an arrow, like with this example. If you shoot on this wall over here and you shoot in the middle, it's pretty accurate, I would say. But if we do 5, 6, 7 scans, and we're gonna end up here, like on the left side, the precision is pretty high, but maybe the accuracy is not pretty high. And that's really important for 3D scanning, that we have get close to the left side, but also if we repeat, and the repeatability is pretty high for that. So how do we certify our scanners? To explain it to customers, I just pulled out this because we're not allowed to show our quality control room, so I made this small example. So what we have is we have an artifact which is measured by a CMM machine, and we exactly know the distance between the two balls, the diameter of the balls. And what we will do is we will scan this artifact on a fixed position in different conditions in the room or axis about 25 times. And then we compare the 25 scans together to the real data, and we get the deviation of it. And this you will get on your certification of your 3D scanner, on the document you will get within the 3D scanner. So that's the way how we certify it. It looks pretty simple, those artifacts, but the cost of one of those artifacts can go up to 8,000 to 9,000 euros, depending on the size. So for a 3D scanner, we normally use 1 meter, 300 millimeter, and 100 millimeter distance of the artifact itself. You can see here some reports. We do also have photogrammetry to increase the volumetric accuracy, and then you will get those information of the distance between the two balls. For sure, we also do work with a lot of research universities for metrology, and they did for sure test also the scanners. So not only we are doing it and we claim, hey, we have the best accuracy, so also we have a third party we're not related to. And we do see that our FreeScan range is a little bit older now, but it's a FreeScan X7, so a little bit older device, but we do also let it certify by third parties. I talked about precision, so that's what we do when we scan it 25, 30 times the part, because we want to know if the scanner has heat management, it's getting warm, so when we scan, we want to have the same results, and that's what the precision is doing. So we really try to have the good results even after 25 scans, 30 scans, or after 2 hours of scanning. And here the example again. On the left side, not a really high precision, also not a high accuracy. Over here we have a high precision but low accuracy. Oops. Up. Okay, that's it. We have the high accuracy at a high precision, but not a really high accuracy. So we shoot always in the same area, but not really in the middle, so it's not valuable for us as for 3D scanning as well. I have also a lot of customers, they ask me normally, because a 3D scanner has 2 cameras normally built in and a projector or laser device. So they ask me, hey Niels, can you tell me, like, if I buy a scanner with a really high megapixel, I get better results? And for me, the easiest example to answer this is to look at the cameras we have on the market. So if we look here, the Canon EOS 200D is around $300, has 24 megapixel. But on the right side, we have the EOS 1D, which cost around about 3,000 euros. So it's not that more megapixel means a better scanner, it's the sensor inside, it's the optics inside, which makes the scanner expensive, cheap, or valuable, or with high accuracy or low accuracy. Then, if we talk about 3D scanning, also really important, the resolution. So how many details we want to see. I always say for inspection or reverse engineering, if we want to check the area over here, so, or the cylinder over here, or the cone, we don't need the highest accuracy possible, because the scanner will always scan with the highest accuracy possible. If we want to inspect the edge over here, for sure I have to go higher, because as more points I get, as better I can define with the triangles my edge. And I showed it a little bit here with the small results. So we see when we use higher accuracy and we want to scan the edge, the real data or the scan data would be closer to the real data. But if we look on the other example, I choose a low resolution, the scan will look like that if we would export it as an outline. Also resolution, I always say it makes your scan beautiful, but maybe not accurate, and also it will increase the file size. So if you scan with a lot of resolution, you maybe get like 5-6 gigabyte files. Maybe you're not able to post-process it, so you anyhow have to reduce it. And for that, I have this example here. So we have a high-resolution scan, 4.6 million polygons, and we have an 18.7 megabyte file with 400,000 polygons. And if you would just inspect the features, the right side would be fine. If you for sure want to inspect the details or the letters and the numbers, which normally is not important for us, the left side would be better for us. The benefits of our solution is, first of all, we have a really unique setup. So you normally have 2 different kind of technologies included to even wider your applications and the versatility. We have free software updates, so you don't need to pay for maintenance. I think that's a big point, and for every update you get, the scanner is getting better. We have a plug-and-play system, so normally you unpack it, connect the scanner, and you can start scanning. We have a live guide how you're going to use the scanner. We have the certification after VDI, VDE, the common one. We have unlimited software seats, so you can install it on as many computers as you want. And we have flexible upgrades, so if you want to upgrade your scanner to a wireless version, maybe in the future, we're gonna give you an add-on for that. You don't need to buy a new scanner. Another benefits of 3D scanning, if we talk about inspection or reverse engineering, it's first of all, you need to measure complex objects. So we know if we work with a normal CMM machine, we have to touch all the different angles and points, which is pretty hard or pretty like a long process. And for that, a 3D scanner is the perfect body. So you can really like just go over it with your hand, get it from every angle, and scan really complex. Another thing is the traditional measurement takes too long. So you're currently using a caliper, and then you like go around, or you have freeforms and you're not sure how to do it. The 3D scanner can, in seconds, scan the object, and you can import it into your CAD system. Another really often case, we have elastic objects. So let's assume with a CMM, you go on a point, you touch it, and it's elastic, so you won't get the real value. And that's why we use a 3D scanner, because it's contactless. You just shoot a picture on it, and you get the data. Another thing, you need to measure again. And that's what a lot of customers forget sometimes. If we go into production and we look over time and we got this product, we inspected it and we inspected the values we thought they're important for the customer. But the customer calls, the part doesn't fit. We send them the report and we say, hey, based on our report, it fits. And the customer says, yeah, but on the backside, there we have the problem. So you cannot remeasure that. But with a 3D scanner, you have the digital twin of the product. So we can just reopen it, measure it again, send the customer maybe the report, hey, from our report it's fine. Maybe it's your machine you have to adjust. And we could help a lot of customers already with this process, with this thinking. Hey, save your files, you can reopen. Maybe you can see even over time if there was another mistake in your production. And most important, measurement is independent from the location, so you can scan wherever you want. Take the scanner, it comes in a small case normally, take it to your customers. Or we have some cases, we're gonna scan big wings. So I have never seen a customer traveling with the wing to a QM room, so we cannot move the part really. So therefore, a 3D scanner is your perfect buddy. So how can we compare it? As I already said, with a caliper measuring tool, it's inaccurate normally and not really fast. A CMM machine is a great tool and will never replace a 3D scanner, or the 3D scanner will never replace a CMM machine. That's what I want to say. For sure not, because we cannot get optical the security you can get with a CMM. But a CMM is really expensive. You have to have a special room, special floor. So also the investment is really high for it. And therefore, the 3D scanner is in some applications where you don't need 1 millimeter, 0.01 millimeter or 1 micron accuracy, the perfect tool. Also, the reports. I always say we all design in 3D, so why not inspect in 3D? And that's with a 3D scanner the benefit. Last but not least, the return on investment for a 3D scanner. So if we look today at the lineup, we can already start for reverse engineering and inspection and the scanner for around 20,000 euros. So what we tell the customers normally, the return on investment on a 3D scanner is 6 to 7 months already. So it's pretty fast, the return on investments for a 3D scanner. If you have want to learn more about the return on invest, we have some guides on our website. And we do have some cases from customers where they explain it more based on the cost. Some case studies I also brought. So we have here petek. Petek is the manufacturer of or the inventor and manufacturer of the halo for the Formula 1. So the halo we know is protecting the Formula 1 driver when he flips over, and the halo protects the head. So I think maybe you saw it already. And they invented this, they produced this, and they also do a lot of race car adjustments, so the chassis inside, the rolling cage, and therefore they need to 3D scan the old chassis because we don't have any CAD data for it, and then we have to reverse it, and then even after they're gonna inspect it again after they finish their whole process. Another customer is ATD. ATD is one of the biggest suppliers for BMW, and they use the free track to scan. So we were not allowed to show on this picture the real parts they scan, but those are bumpers from BMW. And with bumpers, you have the problem with the elastic, in that if you touch with the CMM, it's impossible. I think now we're going to show you live how 3D scanning works really shortly. So just go back for a second. If we look on our software, the software itself is pretty easy explained. So we have the same software for all the scanners. You have the scan mode, so which scanner is connected. You have the calibration, you have the scan, you have the post-process, and you have the measurement. So let's jump into the scan. Now I clicked the wrong button. We don't want to scan, we just want to go first. On the scan mode, I want to show you what kind of options we have. So first option we have is the track scan. So we use the tracker and the scanner. The second option is we use only the scanner to scan something. So we have to use markers. And over here we have our probe. So you can also measure with the probe. The tracker will track the probe, and then you can maybe go deeper or like get some holes with the probe with a really high accuracy. I'm gonna show you the track scan today. So, this is ready. I move the scanner a little bit closer. I click on new project. TTT should be fine. Choose the resolution. I think we don't need a high resolution for the scan. We apply. I take my scanner. Thank you. Now I just need to go on the object. The scanner will already be recognized. We have the distance bar on the scanner itself. If I have the perfect distance, the scanner will light green. Or on the left side, I also have it. If I'm ready, I'm just gonna start and go over the object and do scan it. We also see I don't have to be connected to anything. I can just go and do capture all the details. The beautiful thing over here is that we really have the option to capture the whole object really fast. And whatever I go to, I don't need to prepare anything. I know that some of the customers, they have a floor. Maybe that you have a lot of vibration in your company because there is like a stamping machine or a milling machine which kind of vibrates the floor. So for vibration in the floor, we can put some markers on the object itself, just 3 or 4. The tracker will always track those markers, and I'm gonna reduce or just calculate out the movement. So, but that's basically how the 3D scanner works. I could just now go around and scan the whole object. Yes, I think for demonstration, that should be okay. So in the next step, I could look at my file, mesh it to an STL, and then import into my inspection software and do. I think we have also some cases with the student Formula E, and they normally measure the chassis. So they want to see if it's if the connection and if it fits. Yes. So the holes. So we're gonna measure this normally. And with this scanner, you can easily, or you can even just go on the most important parts, scan these connection parts, and then just measure that. I think that was it from my side. If you have any question afterwards, I'm gonna be over there and can hopefully answer you all the questions about 3D scanning. Thank you.